Assalamualaikum. My name is Afika Dana Meti Muhammad Afri. My metric number is 241112751. So today I want to explain about the Reynolds transport theorem. What is the Reynolds transport theorem? RTT is a fundamental equation that links change in a system properties to change within a control volume. Second is it accounts for time-dependent change in properties like mass, momentum, or energy as fluid moves through boundaries. For concept of RTT, number 1, RTT provide a framework for relating the rate of change of a property in a system to the flow of that property through the boundaries of a control volume. Number 2, this is especially useful in situations where the system is dynamic and material flow in and out of the control surface. For Formula 1, we calculate how a property changes in moving system. What is B? SYS. B for extensive property, SYS is system. So B SYS represent a property of the system like mass, energy, or momentum. This property can change over time due to the inflow and outflow of fluid or change inside the system itself. We have to calculate B system, time plus total time minus B system, time, because we want to know how much the property B changes in the system over a short time. B system, time plus total time for property B at time plus total time for B system, T property B at time. Subtracting them give the total change of B during total time. What happens when total time is 0? When total time is 0, so we calculate the rate of change B as dB SYS over dt. Breaking dB system over dt into two parts. First, change inside the control volume CV. The formula is dB CV over dt. Second, flow in and out through boundaries. The formula B dot in plus B dot out. The final formula we can get dB system over dt equal dB CV over dt minus B dot in plus B dot out. How we want to calculate inflow and outflow? The formula using B dot in equal B rho VA. B for property per unit mass, rho density, V fluid velocity, A cross-sectional area. Formula number 3 is for feed CV. First, we have to use integral. First, integrate inside the control volume. The property can increase or decrease over time within the space. The formula integral CV rho P dV. This term represents the rate of change of the property over time within the feed CV. So we can get d over dt integral CV rho B dV. Second, integrate across the control surface. Integral CS rho B V dot N dA. This measures the net flow of the property across the boundaries. Formula number 4 for alternate RTT. This formula is just different way to writing equation for a fixed CV, so it might change in two ways. First, because of time, and second, because of position. So the formula use a partial derivative to highlight the time change inside the space. For number 5 and 6 can be derived from the general RTT fixed control. When the control volume itself move or deform, the RTT must be adjusted. In this case, we account for the absolute velocity V of the fluid. So the formula for non-fixed CV is dB system over dt equal d over dt integral CV rho P dV plus integral CS rho PV dot N dA. For formula number 6, in steady flow, the property B inside the control volume does not change with time, meaning d over dt integral CV rho P dV is equal to 0. As a result, the time derivative of P system depend only on the flux term. So the final formula for steady flow is dB SYS over dt equal integral CS rho PV dot N dA. Simplify the surface integral. So integral rho PV dot NDA is split into contribution from well-defined inlet and outlet. For this region, it is common to approximate the integral using the average value of the property across the cross-sectional area A using the uniform flow. To take mass flow rate, the mass flow rate m dot for a single inlet or outlet, the formula is m dot equal rho multiply V multiply A. P rho for average density over the cross section, V average relative velocity normal to the surface, A cross sectional area to the flow. Substitute this into the flood term given. For outlet, rho PV average multiply with A minus for inlet, rho PV average multiply with A. Incorporating the accumulation term in RTT is d over dt integral CV rho P dV. This represents the time of change of the property B within the control volume. We retain this term from time-dependent process. So final form of the RTT combining the accumulation term and flood term, and we get the final formula of RTT.